Recall that a motor uses electricity to rotate. In residential HVAC systems, compressor motor, condenser fan motor, and evaporator blower motor are found. HVAC systems depend on motors to move air, pump water, and run compressors. Single-phase motors are commonly used in residential HVAC systems. There are several types single-phase motors. Common terminals in all motors are start winding, run winding, common connection. When we inspect motors, we perform general inspection, earth resistance test, power supply test, winding resistance test, and running amps test. Let's dive into the details about these inspections. General inspections include visually inspecting the motor if it is burnt or damaged. Next, we manually rotate fan blades and observe for smooth and free rotation. Finally, we check the wiring connections if there is any loose or damaged wire. For further inspection of the motor, we need a digital multimeter. Recall that we insert the black probe into COM and red probe into V omega of the multimeter to test resistance. As we are performing the earth resistance test, we need to turn the selecting knob to the required range in ohm symbol. We have to place one of the leads on the motor body and the other on earth wire. A good motor should show a resistance value less than 0.5 ohms. Any value greater than 0.5 ohms indicates that there is a problem with the motor. Before performing this test, we need to disconnect the power supply to the motor. In this test, we check the resistance between the three terminals of a motor. Recall that start, S, common, C, and run, R are the three terminals in single-phase motor. We have to check the winding resistance, as shown in the video. As a rule of single-phase motors, the resistance value of S to R should be the highest, R to C should be the lowest, and C to S should be between the above two values. The resistance value of S to R should be equal to the sum of R to C and C to S. We need to check the full load amps, FLA, as shown in the video. The FLA represents the maximum amount of current that should be drawn by the motor. The FLA is written on the nameplate of the motor. The current drawn by the motor should not be above the specified FLA value. It should be at or slightly below the given FLA on the nameplate. If the motor draws current more than the FLA, it means the motor is damaged.